EHV circuit breaker. General overview as per CEA norms. About me. Myself, Sanjay Kumar Srivastava, retired Deputy General Manager of Power Grid Corporation of India Limited and consultant in Power Grid Energy Services Limited for 400 by 220 by 132 kV AIS substation. I am also associate member of Institution of Engineers. My 35 years experience in EHV substation of power grid is focusing towards from basic knowledge of EHV substation equipment to operation and maintenance level work of 400 by 220 by 132 kV substation equipment. Here circuit breaker is being explained. Scope. Scheme of circuit breakers as per CEA. Operation of circuit breakers. Short details of SF6 less circuit breakers. AIS EHV circuit breakers are specially designed for use in substations that handle high voltage electrical power transmission and distribution. These breakers utilize air as the primary insulating medium between energized parts. They are a crucial component for protecting electrical systems from overloads and short circuits in ESB network. AIS EHV circuit breakers are designed to interrupt fault currents, short circuit and overloads both within high voltage electrical systems. They act as a safety mechanism, preventing damage to equipment and ensuring reliable power delivery. As per CEA guideline, circuit breaker used in AIS substation shall be of SF6 outdoor type C2M2 class as per IEC 62271-1 and 100. However, for reactor switching, circuit breakers shall be M2 class. The circuit breaker shall be of live tank or dead tank type. In case of dead tank type circuit breaker, conventional outdoor CTs shall not be required. However, bushing type CTs shall be provided on either side of circuit breakers. Circuit breaker shall be provided with the three identical single phase units with single and three phase auto reclosing features as applicable. In case of 132 kV system, circuit breaker may be of three pole type if single phase auto reclosing feature is not required. For 33 kV system, circuit breaker shall be of three pole type. Circuit breaker shall be provided with the anti-pumping and trip-free features and shall be remote controlled from control room with provision for local and manual control features. Circuit breaker shall be provided with two trip coils and one closing coils per operating mechanism for 132 kV and above. It shall be possible to trip the circuit breaker even in the event of failure of auxiliary power supply to the mechanism. The breaker shall also withstand all dielectric stress in open condition at lockout pressure continuously. Circuit breakers shall be capable of clearing short line fault with source impedance behind the bus equivalent to symmetrical fault current. Circuit breakers shall be capable of switching on off shunt reactor without exceeding over voltage limits mentioned elsewhere. Circuit breaker shall be capable of interrupting the steady state and transient magnetizing current corresponding of power transformers. SF6 gas shall be as per IEC 60376, 60376A and B. SF6 circuit breaker shall be supplied with gas for first filling and minimum 20% extra gas in non-returnable sealed container. SF6 gas density monitor with temperature compensation shall be provided with respective pressure switches. It shall be possible to dismantle the monitor without draining the SF6 gas. The contacts of density monitor and pressure switches shall be provided for permissive in closing and tripping operation. The 765 by 400 kV circuit breakers shall be provided with pre-insertion registers wherever applicable for the line feeders or controlled switches devices wherever applicable that with reactor and transformer switches breaker to limit the switching surge over voltage. Controlled switching devices. The control relay shall have facility to record and monitor the switching operations. It shall be possible to make adjustments to the switching instance to optimize the switching behavior as necessary. It shall be provided with the self-diagnostic facilities, alarms, and downloading and display facility for the settings and measured values. The controller shall be PC compatible. The controller shall meet the requirements of IEC 60255-4 Appendix E Class 3 regarding HF disturbance test, fast transient test as per IEC 61000-4 Level 3 and insulation test as per IEC 60255-5. In case of breaker to be operated manually, controller shall also get manual command from remote. The controller shall be able to analyze the current and voltage waves available through the signals from secondaries of CTs and VTs for the purpose of calculation of optimum moment of the switching the circuit breaker and issue command to the circuit breaker to operate. The controller shall also have an adaptive controller feature to consider the next operating time of the breaker in calculation of optimum time of issuing the switching command. The accuracy of the operating time estimation by the controller shall be better than plus 0.5 millisecond. The controller shall have time setting resolution of zero point 0.1 millisecond or better. Constructional feature. First, contacts. The gap between the open contacts shall be such that it can withstand at least the rated phase to ground voltage for 8 hours at zero gauge pressure of SF6 gas due to the leakage. The breaker should be able to withstand all dielectric stress imposed on it in open condition at lockout pressure continuously. That is 2 pu across the breaker continuously, for validation of which a power frequency dielectric with stand test conducted for a duration of at least 15 minutes is acceptable. If multi-break interrupters are used, these shall be so designed and augmented that a uniform voltage disturbance. If multi-break interrupters are used, these shall be so designed and augmented that a uniform voltage distributions is developed across them. Calculations, test reports in support of the same shall be furnished. The thermal and voltage withstand rating of the grading elements shall be of adequate for the services conditions and duty specified. The SF6 gas circuit breaker meets the additional requirement. All the gasketed surface shall be smooth, straight, and reinforced, if necessary, to minimize distortion and to make a tight seal. The operating rod connecting the operating mechanism to the arc chamber shall have adequate seals. The SF6 gas leakage should not exceed 0.5% per year, and the leakage rate shall be guaranteed during the warranty period. In case the leakage under the specified conditions is found to be greater than 0.5% per year, after commissioning of circuit breaker during the warranty period, the manufacturer will have to supply free of cost the total gas requirement for subsequent 10 years based on the actual leakage observed during the warranty period. In the interrupter assembly, there shall be an absorbing product box to minimize the effect of SF6 gas composition products and moisture. The material used in the construction of the circuit breakers shall be fully compatible with SF6 gas decomposition products. Each pole shall form an enclosure filled with SF6 gas independent of the two other poles for 800, 420, and 245 kV circuit breakers. And the SF6 gas density of each pole shall be monitored individually. For circuit breakers of voltage class of 145 kV or less, a common SF6 scheme density monitor shall be acceptable. The dial type SF6 gas density monitor shall be adequately temperature compensated to model the pressure changes due to variations out in ambient temperature within the body of circuit breaker as a whole. Separate density monitor and dial type temperature compensated pressure gauge is also acceptable. The density monitor shall have graduated scale and it shall be possible to dismantle the density monitor for checking replacement without draining the SF6 gas by providing suitable interlocked non-return valve coupling. EHB circuit breakers capable of withstanding a vacuum of minimum 8 millibars without distortion or failure of any part. Sufficient SF6 gas is provided to fill all the circuit breakers. Spare gas are supplied, procured in separate unused cylinder as per requirement. Detail of sulfur hexafluoride gas. The SF6 gas shall comply with IEC 60376 and shall be suitable in all respects for use in the switchgear under the operating condition. The high pressure cylinders in which the SF6 gas is shipped and stored at site during erection shall comply with the requirement of relevant standards and regulations. SF6 gas shall be supplied in returnable cylinder for all circuit breakers at the time of erection and commissioning. However, SF6 gas for spare circuit breakers and mandatory spare quantity of SF6 gas shall be supplied in non-returnable cylinders. Further details of circuit breaker will be presented in the next unit. Thank you.